Welcome back after a little while. Finally, we designed a retractable landing gear for our SUX and also movable flats and make it much more lightweight, and also a lot of investigation was done on lightweight printing. This is an amazing print here. This fuselage is again over 100 grams lighter than this one, which is already lighter than the last flying SUX. So many news to reach our goals. Make this startable from grass surface and give it super flight performance. And also for our Harrier fans, this lightweight construction will make the VTOL possible. Let's start with the building process of this one and then take a look at all the details. Let's go! The prints you can see here were done some months before and the quality was not that perfect, so I decided to sand it completely to prepare it for the resin process. In the first step I'm using 80 grit and right afterwards I do the final sanding with 100 grit. Then everything was brought to the composite room and I started the resin covering process. For this I'm using a mixture of 1:1 by weight from resin, epoxy resin and spiritus to make it much thinner. With this super liquid resin mixture I can impregnate the whole structure much faster and much deeper. It becomes like water and is reinforcing the whole foam structure. It also becomes possible to use the absolutely minimum amount of resin to keep the weight as light as possible. After applying the resin, I'm using some paper cloth to remove the excess resin to become an all-over matte surface. All parts you can see here are printed with just one wall and about 5 to 7% infill, and they would be too weak without the resin, so it's a wonderful combination to get the maximum out of it by having or gaining just the absolute minimum of weight. Afterwards, all parts were put into the oven and cured at about 32 degrees Celsius for 12 hours. And this is the main fuselage segment. This was covered inside and outside to make it as stable as possible. Weight of this fuselage is 462 grams before working with the resin. Let's see what is afterwards. Here's the mixture, 35 gram resin and 35 gram spiritus, and it really looks like water. This is the resin spiritus mixer, super liquid. This goes really fast. So the job is done and there are still nearly 15 grams left of our resin. As last step I was using some paper cloth and remove the excess resin where it was shiny, and I'm really happy. This was quite fast, I think about 10 minutes, and the whole thing was covered. And let's give it time to tomorrow to cure, and then let's check the weight and the stability. The weight after the resin covering, 483 grams. Here we got two different parts. The right one is already covered with resin and left you see the pure printed part. On the wings and vertical stabilizers I covered the hinge from the rudder and aileron with a plastic tape just to save it from impregnating with the resin. This should stay soft and movable, that it is running easy and doesn't need too much power from the servo. Besides sanding, this is all preparing that is needed, and right afterwards you can start with the resin. Here we got the parts, and right after laminating and hardening, the surface is a bit rough like sandpaper, and we will smoothen it up by grinding with 240 grit sandpaper, and then it is ready to go. Now also this tape can be removed. The aileron still moving. This works nice. Okay. Also these grinding pads can be used. They are much more flexible, especially when we got some round surfaces. They are very useful for this finish job. So let's take a look to the weight gain from the wing. Just 1.4 grams. 1.4 grams of epoxy for the whole wing. So the weight of the front part is 245.6 after laminating. So let's have a last view on the weight of the last prototype, 1876. And let's see what this will weigh with the gears and the new wings. All the technique has to be removed from this one and put on the next. So all the technique is removed and the empty weight of the old SUXR is almost exactly 1200 grams. Next I installed the servos for the main gear doors. I'm using super small servos which weigh about 6 grams and has a kilo of torque, but this is quite enough. Also I'm using a 2mm plastic tube and a 0.8mm metal rod, which is super flexible and can move the whole thing. For adjusting all the gear doors, the stopper inbuilt that this metal rope can't jump out. So let's make a weight comparison. This is just to tear, you will see in some seconds why. And put on the new SUX, and here are all the missing parts and this plastic box, but we don't want to weight of this plastic box, so that's why I tear it. And we got most exactly 1400 grams with gears and with wing servos included. And let's take a look to the old one. There it is. So, and here we just have to put on the nozzles. The canards are inside the fuselage. So, and here we got 1200 grams, 200 grams less. No retracts and no servos. And I think this is a good start for the new one. For this jet I'm using QX motors with 2400 kV. They will run on 6S. Let's put in the new powerful 6S EDFs. After removing the flanges, I have to remove the outer ring here with the Dremel, because the diameter was big too much. And I also have to size up the very front of the EDF. The main engines are always the first parts I install, and right afterwards I go on with all the electronics, servos, receiver, and make the jet complete. So let's do the first thrust test with the SUX. Here's the scale. Here we can see the amps and throttle up. Okay, 2.5 with a cold battery. Do it again. Take a look on the ESC temperature. What's the max? This okay. They're cooling down. Yeah, about 50 degrees is absolutely okay. Battery 44.8. Also okay. I would say this is a good setup. This works. Let's see if we can measure the temperature from the motors. 34, 40 degrees. This is also super. Everything under 60 is good and stays for good efficiency. So as you saw, this was quite work intensive with all this sanding, and that's why I spent a lot of time to improve the print quality and the print settings. And even here we can see the difference between the further ones and the latest results. Finally, I could get rid of this mess. This really disturbs the stability of our prints. The goal is that we get rid of all these sanding works and just cover up the surface with this thinned resin, because this gains a lot of stability and also give a very nice surface which can be painted afterwards and is also more heat resistant. In the next videos I will show some tests for this. And the cool thing is we gain very little weight. Yeah, this is about just some percent. You saw on the wing 2 grams, or on this whole fuselage covered inside and outside 20 grams. And especially on the ducting, we need a nice smooth surface for good efficiency. This we can all reach with this resin technique. Something to know when you get these new parts. In the next weeks I will do the fly tests and check all the constructions. We will offer this slats and gears as extension set, so for all the customers that already got the SUX can buy just the extension set, and we also will offer a new complete set where is everything inside. When it is ready for offer, I will tell you in one of the next videos. Okay, let's go to our Harrier project. There I did a lot of investigation to figure out what is a good start with the VTOL. You know, we bring it to fly, we can hover it, everything is done, but the next step from hovering to normal flight, this is a big leap. We need 2 things for reaching this. At first, we have to make this much more lightweight. This is nearly reached with the new print technique. So we can save about 10 to 15% just of the weight from the construction. This is a lot. And the second thing is we need more power. And this power compared with better efficiency. To get the best efficient setup, I will go different ways. You can see here, this one is a bit bigger. This is our Harrier upsized incuria to 118%. So everybody of you that already purchased the Harrier STLs can do the same. Just upsizes in all direction to 118%. And inside here is a 105 millimeter EDF, and this one has a very good data sheet for its efficiency, while this one has a quite high airspeed in the airflow, and this is superb for flying like a jet, for fast flights. But it could be that this one has a better efficiency for hovering, and we need much more hover time to do a safe vertical lift-off, normal flight, and do especially a safe vertical landing right before our battery is empty. So I will do a lot of tests with this also to figure out if it has the better hovering efficiency. This is important for VTOL. While this is quite perfect for flying like a jet, for the next step we need more hover time. And also the bigger size helps me to keep this jet visible when I do the first transitions test in safety height, and there's a lot of more space to integrate all the technique, so this makes the whole test flight process much easier. And also I want to bring the wing load down with all the technique installed, that this plane flies safe as possible. That's for the moment. A lot of work to do in the next weeks, and if you like to support these works and support me making the videos, you will find some links in the video descriptions. You become my Patreon, where I share a lot of behind the scenes details. In the next video you will see a complete tutorial how to do these prints. We see us in 1 week in the next video. Stay safe. Bye bye.